welcome everyone to part 2 of our Roundtable sessions. We're joined today by two absolutely brilliant people. I'm really excited to bring them together for a conversation that's going to span all things AI, business building, investing, and wherever else they want to take the chat. First, let me tell you just a little bit about Lake. Lake has an incredibly impressive and incredibly expansive background in tech investing, including hands-on product and engineering at Alibaba and Yahoo, time spent at various Silicon Valley startups, building out Alibaba's B2B marketplace, investing in, guiding, mentoring AI startups. She has this incredible commitment to education, making a positive impact in the tech space through nonprofits. She's on various boards. She's just incredible. She has so much ground we can cover with her, which brings me to our good friend, Matt Reustle, who is someone who has a deeply curious mind, a passion for the art of startups, business building, markets. Matt has a great podcast called Business Breakdowns, where he explores how companies are built, how they really work, lessons to be learned from the people who are truly in it. So when we set out to craft a conversation with Lake, I knew Matt was the person to bring in. So for those of you joining us live today, I hope you enjoy this conversation. Please jump in with questions towards the end of the chat. You can do that just in the chat feature, or you can, if you're brave, jump in with us, turn your camera on, your microphone on, and we can have a bit of a group conversation, which is something we love to do here at Collective. So with that, I'm going to step out of the way and hand it over to my good friend, Matt Reustle.
Thank you, Shannon. And Lake, I think Shannon tapped into your extensive experience in AI. And I think a lot of what is dominating the headlines revolves around some of the higher level observations. But I think you've been paying attention to the second order impacts that AI is having on different pieces of the infrastructure ecosystem that support it. And I just wanted to dive right into that first. So maybe you could start out by explaining what is happening in the power and electricity markets as it relates to AI and how you're seeing that evolve.
Yeah. So, it's quite interesting because, if you ask the question 7-8 years ago, we probably don't even think about electricity. And we're not really asking computer science professors to talk about electricity, right? So what is really changing is because deep learning, and particularly generative AI, start taking off in 2022. So what I've seen is that because there are massive usage of AI, particularly generative AI, large language model, what we're seeing is massive build-up of global data centers and massive usage of energy for compute on both on training and inference. So what's happening now is that, we look at a global data center electricity use. We're actually talking about just from 2024 to 2028, we're looking at least 2x of electricity use. And putting the numbers, think about entire US electricity and how much being used by data centers. In 2023, it's about 4.4%. And we're looking at roughly about 7 to 12% by 2028. So it's safe to say that, roughly about 10% of the electricity that generated and used in the US will be for data centers. So that's a crazy number.
Absolutely. Yeah. Keep going.
Yeah. I was just saying is that what's interesting is that all these projections are mainly used focus on large language model. But what I've seen in the last 2 years is that we already evolved from large language model to multimodality, which means that not only just text, but we have images, we have videos, we have voice, right? And now we're talking about physical AI, robotics. So each of those evolve of the models is significant increase of use of compute. Text, for example, they say Matt is 4-letter, right? However, if you use your picture right now and use your video now, we're talking about thousands, if not 10,000 size of the data that we're using. So that makes a lot more sense, and then open up the imagination of how much more energy we're going to consume.
Yeah, it's interesting. I read somewhere the Google search relative to an AI query an AI query uses 10x the amount of electricity that a Google search does. And then once you get into the agentic workflows, it can be up to 40x. And it really reframes in my brain just how much electricity is being used. What are the solutions to fill that gap? And how do you see that bottleneck kind of playing out where we are today versus in the future? And just basically what needs to happen such that this isn't the main bottleneck that stops AI development going into the future?
Yeah, so I think people are start realizing there's going to be a bottleneck. So we're not, interestingly, if we're looking back 5 years ago, when we may think about different bottlenecks, we may think about it's going to be chips development. We might think it's a talent development. And today, it's very clear. We're looking at how do we already know that the build-up of AI will continue to grow regardless of geopolitics issues or whatever challenges there are. It might be even be more acceleration due to that. So the solution that we're looking at, basically, people with different background are looking at different type of solutions. For example, people are looking into clean energy. You can see clean energy and also traditional energy investment has been going up quite a bit in the last 2 years. And the other solution that people are looking at is, can we look at more efficient type of compute from both hardware perspective and software perspective? So what does it mean? So can the chips be more efficient, support AI model training and inference? Can it use less energy? So particularly inference chips, we see a lot of different new development, new innovations regarding to being energy efficient. On the software side, so you think about if the chips and all robotics and arms as the physical artifacts, we have to think about the brain as well, which is the software. So, so software, how does it work to be more efficient? The number one is that, for example, one of the companies that we invested is called AnyScale. So they're the orchestration layer of distributed AI workloads, which means that drives that compute intensity and optimize utilization. That's really important, because when it comes to utilization, we all know that there's a lot of enterprise that bought a lot of Nvidia chips, right, over the last few years. We kind of hoarded a lot of chips. But if you're looking into the data that how much has been really utilized, you're going to see a very volatile chart in terms of the utilization, the time and how it was distributed, and it was not efficient. The utilization currently of NVIDIA chips, this is the data from last year, looks like we're only about 40% efficiency. There's a lot of room to grow. So the other thing is, in order to get there, you really need to know in terms of your GPU performance, what's the current pricing, what's the carbon transparency, right? So all the different things that you need to understand. So that's why it was really interesting in the last few years, particularly last year, I was giving leadership trainings, and that's the biggest transition right now for the technology leadership team, particularly CIOs and CTOs. You have to think about like a CFO now, because you have to think about energy, you have to think about compute as you're thinking of all the commodities, right? So this is a very important supply chain that you need to manage, and you have to manage all those AI providers and vendors as the traditional way you manage the vendors. So what's the backup plan? What's the forecast? What's the utilization? And particularly nowadays, if you look at the SaaS software, which is powered by AI, and a lot of those applications today no longer charged by seats. They charge by utilization. So how do you predict your utilization for organization is really important. And then, there's many different ways that we can talk about in terms of cooling as well, right? Data center has cooling issues. I think, Matt, you mentioned this before, is how we address the cooling situation.
Yeah, one more question on the software side of things. I certainly understand. You have chips. You're not using them to full utilization. There's basically this inefficiency that exists. It's kind of the Amazon Web Services model of maybe we can be more thoughtful, and sell that excess capacity? What is actually happening at this level? Is it that you could take that chip capacity and sell it to external customers? Is it you become more thoughtful about making sure that you're maximizing each chip's utilization within your organization and you reduce the number of chips? What are the mechanics that are actually going on there?
Yeah, there are multiple steps. The first one is you understand how your utilization is today, right? So what's happening is sometimes it's very simple things. So one of the Fortune 500 companies and had a conversation with me a while back, and then we advising them on AI strategy. So the first thing I actually suggest them to take a look is how many AI projects are currently running that you no longer need it. So then they already, because every company has their research team, different organizations, they're running a lot of experiment. However, the project is dead, but the computer is still running. So by that alone, that particular company already cut down 40% utilization. So, and second is that how do you actually, for example, AI model is you don't always have to use the newest model. So I think from a researcher point of view is, of course, we'll want to aim for the best, highest accuracy, the fast response time. But when you put into real world situation, which is basically what I teach at Carnegie Mellon University, is over the last 10 years, I teach how do we actually build and tune AI models in a real world situation. You'll find out the cost is a significant consideration, right? And efficiency is a significant consideration. So when do you call the model? When do you not to call the model? What kind of model you're going to use is another thing that we recommend enterprise to take a close look at. And the third is the considering, this is not related to the enterprise side, but more from the frontier labs, is how do we think about building the models that can be more efficient in energy consumption when it comes to training and inference. So one thing that's really, really important is that the last 10 years, most, I would say, milestone development on the AI algorithm is inspired by neuroscience. And so that's why we call it neural network today, right? So deep learning, neural network, how neurons work together, how we make decisions. We learn a lot from how our brain functions. And same thing, if you think about, you and me right now having this conversation, we both use the training method, but we use a lot of inference, but we barely use any electricity. So our brain is the most efficient computer here. It's a very small footprint, super efficient. So we have to think about the models today is that how our information are collected, trained, and stored and served in a type of the way that our brain works, right? So this is we call it first principle. There's a lot of research on neuroscience side and now blended into computer science. It's super fascinating. So can we do something like this? If that really happens, I think there are a number of companies actually in this field, and one of them are in our portfolio of Sancus Ventures. So I think if any of those companies succeed, I think they're going to pose actually significant threat to all the foundation models today because most of them are trained on transformer. Mm-hmm. So that would be quite interesting, right? So I think we're hitting the energy bottleneck, which push all these models be more efficient. And then going back to on enterprise side, not only operational, we can be more efficient. How do we actually predict the outcome, the utilization? So that's why, going back, so what should we do as a CTO? So CTO need to work really closely with CFO today to predict. This is actually a really complex prediction here, is that how much utilization you can use based on the model efficient today, how much you're going to use it going forward. And most people don't have a visibility today, right? Because you don't even know what model is going to be released next and how it's going to impact the cost and also efficiency. So as a result, there are going to be more and more companies like this to help you to predict, to plan in terms of cost efficiency. And that's, I think, is one of the trends that we're looking at right now. And there are also some of the companies and some startups as well to help larger companies to understand that.
Yeah, it's an easy dynamic to gloss over with the amount of capital that's going into some of the foundation models and LLMs. But the underlying cost that comes into place, and if you run any of these experiments or developments, you could see how much the costs start to pile up. So I
Yeah.
think there's really something there. Tying it back to your earlier point on chips, I know that there's Nvidia clearly in pole position, but coming out with the most advanced, technologically capable chips. And there's a lot of private players that are trying to, at least under my understanding, introduce more efficient chips, kind of fill in the gap, which I think alludes to what you were describing. Do you have any view in terms of their viability in the market in the future versus Nvidia, who clearly kind of has all the mind share and market share today?
Yeah. This sounds like a question that a lot of my LP ask me. Should we bet on Nvidia? Okay. So to talk about chips, there are actually two different types of chips. One is the training chips and the other is inference. Nvidia clearly has the leadership position in the training chips. And then they've been trying to continue to lead in the inference space. But inference is quite complex. And so because we have to, once the difference of training and inference, to think about training is like you're learning. So it's very intense when it comes to compute. But when you inference certain things, there are many ways to make it more efficient. So one example I always use this example is, let's say if you go to the airport and then watch, for example, LAX traffic, and you ask the questions, who are those people? And then that inference is going to take quite a long time, right? Because you ask a very open question, who are those people? So now I have to understand each person's identity, what their job, and then all different things. But if you ask a very binary question, because if you only care about, for example, how many of them, let's say, I'm just come out with this example. Let's say you want to do the expansion of the restroom facility, and you just want to figure out how many people actually are gender-wise, that who is going to use what bathroom. And then that is a very easy binary, quick calculation, right? So that's why when we think about using inference chips, is then a lot of inference chips today are used for we call the specialized use cases. So because when you have those kind of little more binary or smaller use cases definitions, then you can optimize those chips for that particular performance. So some of the chips today, if investors want to invest in chips, then the first question I ask, are you optimized for training? Are you optimized for inference? If you optimize for inference, what are the use cases you optimize for? And then the next question is what are the trade-offs, right? Because when we think about the chips, particularly inference chips, then we will talk about footprint, how big it is. Can it actually fit in the phone or smart cameras, right? So some of the inference chips are quite significant when it comes to footprint. What's the cost of it? What's the energy consumption? And then you only ask the question is that with the speed of training, right? So quite often you have a startup come on to approach you, say we're 10 times better, 20x cheaper. And what are the trade-offs? So those are actually really, really good areas to continue to explore. And the other thing is to think about optimization levers on the software and hardware side, is that it's any model compression. Are they using any specialized smaller models on the software side? Are the chips developing a way to kind of optimize for some certain type of models? And we're seeing some are. Do you have a smarter routing? Do you have post-training customization needed? And do you have like better inference stacks? So there's a lot of different nuance in this, but it also means that we have a lot of room to improve. Or I think I'm optimistic, and I think there's a lot of room to optimize, and then we can see a significant reduction in terms of energy consumption.
And if you talk to incumbents, they'll tell you that the startups will have a very hard time, even on the inference side of things, in terms of the complexity that goes into actually making these chips and making them viable and reliable and consistent. Do you have a strong view on whether these private players, and you don't have to isolate one versus the other, but if they actually have the capabilities, the capital, and the time and market to actually succeed?
That's the reason I don't invest in chips. I think they're still going to be good investment, but because it really depends on, when we make those comments, what type of lens are you looking for, right? So if you look from an investment perspective, the reason I don't invest through this doesn't mean like I don't think it's incredibly important. The challenge, I think, with anything related to chips development, because number one, you're going to tap on manufacturing and access, supply chain access, then which in turn you're going to touch on geopolitics sensitivity there. I also don't like is cynical, means that you currently everyone's building out, and by the time they're manufacturers and distributed, and then maybe it's overproduction. So they're not as agile as the software. And then I personally like the layers above the chips, and that can be used for all different kind of hardwares. They can be optimized for different hardwares. In the meantime, they can also be supported to all different frontier labs, right? So as we know that people always talking about AI today, they mainly talk about foundation models. But there are so many different layers there. So what I like is that the layers sitting between foundation models and chips, and they can work with everybody. So as long as you bet on the overall industry is going that way, so this kind of middleware or software infrastructure can support all foundation models, in the meantime can work with different kind of chips that will likely to capture most of the value.
And we'll get into some of the dynamics in the cooling market, which you referenced, and I think you tapped into it a bit with this growth in data center demand. But can you just kind of give a sketch of what is actually happening, how cooling comes into play, and some of the unique dynamics that you see as opportunistic in that side of the market?
Well, let me just say this. I'm actually not an expert in energy generation and optimization. But being said, I think every watt of compute becomes heat. And then I think cooling is no longer facilities overhead, is actually a compute enabler, and then basically a constraint. So that's why it's really, really important to look into this area to see whether there are any kind of potential innovations around it. And the other thing I want to mention is that I actually started looking at fusion technology back to like 25 years ago. And at the time, nuclear fusion. So at the time that, talked to some of the leaders in the space, they said it's coming in the next 5 years. So this has been 25 years and nothing has happened. I do think that one of the main bottleneck is that basically nuclear fusion is really one of the challenges, that how do you contain that much of heat, right? So as we looking into different options to be more energy efficient and I'm looking for new sources of energy, I think that even push more of a cooling innovations and say, how do we solve this? Not only just for data center cooling issue, but also how do we solve the cooling issues for nuclear fusion, which is going to be one of the major clean energy resources, right? So right now, if you think about today of all the hyperscale energy used today, roughly about 7% of them are used for, those are hyperscale energy use are actually in cooling. And then if in some of the less efficient facilities, data centers, that energy could exceed over 30%. So when we think about different ways to cool it down, that there's direct liquid cooling, for example, but that whole adoption right now is still roughly about 20 to 25%. So, and then the rack density in the data center is really increasing, basically materially due to AI GPUs. So that's why I think the concept or the ideas of SpaceX could take all those data centers to the space, and then you kind of naturally cool down those all this, basic GPUs, is actually sounds like a little bit dramatic, right? So like futuristic, but it's not really too far away, and it actually make a lot of sense. So of course, there's a lot of details to try to solve it, and I think that elements alone probably contributed to this 1.5 trillion valuation recently being circulating in the market.
Yeah, it's very clean up there too, so you don't have to worry about the air purification on top
Yeah.
of the cooling mechanisms. Are there similar software-esque or certain manufacturing solutions that can improve efficiency? I kind of understand, the chip density for AI is creating this dynamic, and at some point that becomes a bigger problem. But are there any things that you're seeing maybe on the ground that that in the private markets or in the public markets that are kind of looking to address this problem?
Yeah, so I think I would say right now we don't have a very clear winner in this place. So a lot of investment are, I think people just start realizing this about early last year. So we Sancus Ventures actually were a little ahead of the game, so we started deploying capital about 3 to 4 years ago in those area, but still it's very early. So I would say some of the progress made, for example, like higher utilization platforms like AnyScale, which is also funded by the founder and chair of Databricks, Professor Jan Stoka from Berkeley. So his research is known in distributed computing. And so Databricks was probably well known by people and to understand like this is very efficient data infrastructure. And AnyScale and his next company is really optimized for distributed computing, particularly for GPUs. So I think that is something that we're seeing is in significant adoption in the last 3 years, from frontier labs to all those major companies using AI. Any large companies that we can think about today, like Airbnb and Uber, all this are using the framework. So that's one thing I would say we see more of a significant development. And the second is that I mentioned is the visibility, right? So we invest in a company called Silicon Data. They're pretty. I would say a lot of people know about them today. So, but what they do is they help you to optimize deployment footprint, because again, as any company like CFOs and CTOs, you really want to understand how do you make a comparison, what are the options of compute, and how do you actually hedge it, how do you trade it, right? So it's become a hedging or trading product today for the CFOs. So it's quite interesting. We don't really see this as a landscape at all, going back to 7-8 years ago, but now compute is going to be treated like electricity. And then I think we are seeing a number of startups coming to the market, not only on the chip development, are actually working on smaller, smarter models, and that is operated on device. So device or any kind of endpoints, or we call it edge. So it doesn't have to be cell phone. It could be your smart camera. It could be robotics arms. But the models tends to be much, much smaller, and then tends to be more optimized for that particular use case. And we're gonna see more and more in the robotics as well. Because if you think about it, let's say, regardless of all this fancy human drawing demos you see, like can flip, right? So the real work that you want a robotics arm to do is to go into can be high precision in manufacturing, for example, in healthcare and surgery, those kind of situations. You want high precision and real time decisions. So that means then sometimes this model needs to be trained to optimize for the use cases. So one of the interesting use case I think related to this is that recently I met a startup that amazing neurosurgeons create this use cases, because that neurosurgeons quite often, like say when they conduct the surgery, open your brain up, and you will see unexpected scenarios, even though, how much, MRI and CT have done in the past. But once you open it up and in the middle of surgery, you have an unknown situation. So, and surgery is something is that experience matters, because you will see similar situation, you're going to recall that information. So the idea they have is they use the camera basically projected and looking at the surgery desk at the real time, basically giving recommendations, research and giving recommendations and research for similar situations, recommend next steps, which is all great. But a couple things are really important here, right? So assuming they have enough training data set to actually get this accurate, but again, they have to see it really, really well. And then they have to think really fast, because then you're gonna, the longer the surgery, you can just say let the model run 2-3 hours and let me come back to it. It's not going to happen, right? So this is the kind of situations that particular model and that particular hardware needs to be trained and optimized for high accuracy, but narrow use cases, but fast response time. So we're going to see more of those kind of use cases push innovations on both software and hardware development.
Yeah, I heard an interesting anecdote recently from Cognex, who does the basically they provide LiDAR and machine vision inside logistics centers, and the conveyor belt with the camera that can say this package is damaged, whatever it might be. And they talked about a similar physical AI use case, which they've seen a lot of development for. And a lot of that's opening up, and you need a smaller model with very tight parameters, but you can update that in the cloud and then bring it back to the device. And you could see how that's, one, both more efficient, but two, also more accurate. I'm curious on the more efficient compute. Where do you think we are? And I'll just say, from the cheap seats, I would say large public players kind of have a bit of openness to spending CapEx on AI development, or even in the operational expenses. Eventually, that cost sensitivity is really going to come into play. But from your perspective, do you think that's really underway at this point? Do you think we're in the early innings? Just to gauge, how this dynamic is going to play out and how quickly it could maybe accelerate.
I think still early. The reason is because, well, I think regardless of what people say, the best way to track what really is happening is see where their spending is going towards. So we spend a lot of time to not only just track all the research and publications and or social media, probably the least that we care about. But we really link to where they spend, right? Say, for example, OpenAI raised the capital. So why they raised the capital, how they're going to spend that capital. And you actually can get a lot of signal out of it, right? And you look at the recruiting signals as well to say, where are they recruiting? What type of people they're recruiting? So that gives you a lot of signal. But today, I think a lot of race is still towards, let's say, let's not mention the names of any frontier labs, but I'll say the most intense compete now is on acquiring high quality data for better training, because everyone's exhausted all the public data today. So how do you get the data that is not in the public area, that you have proprietary access to, and you can basically figure out some way to do product feedback loop, allows the user continue to annotate for you. So that is the number one, or at least one of the top 2 or 3 challenges they have. So how do you get this data? So that's why it's even more important for some of the foundation models who don't have access to a variety of data, right? Some of the models are very good at getting, I would say, become on the leaderboard of large language model, but they don't have access to for 10 or 20 years of accumulation of images and videos, like a Google, for example, right? So how do they actually get access to them? So one of the ideas is to create a new applications, create a new devices, particularly consumer can use those devices and continue to give you feedback loop. So that's why you can see the build up of the glasses, the cell phones, right? So you can track all those recruiting trends. You can see the hardware's become hot again because everyone want to get to the endpoint that they have more access to the data that others don't have. So that is one area. Then the other area that I think that people are thinking about is how do I actually get access to secure the chips supply? So that's why you see a lot of Nvidia really enjoy this because they actually are become strategic investors in a lot of different companies, including some of our portfolio companies in robotics. So why they're so active in terms of investment? Because then now that's great. So I invested in you, and you use more of mine, and then of course that from companies willing to take the investment because that may also come with the security in terms of supply chain. So that's another huge area that all the frontier models going towards. When it comes to energy efficiency, people realize that is important, but you still have other choke points that you need to solve today. So that's why I think in terms of hiring, in terms of priority, I think we're still early.
I know if I'm asked to do more of those recaptchas of identifying all the motorcycles in a picture, that I'm training AI devices instead of the Waymo cars or whatever it might be. But yeah, there's creative ways to come up with this training, and certainly interesting to hear about it. On your point about Nvidia investing into a lot of these upstarts or new developments, there's this interesting feedback loop that's going on, and we could debate it from both sides. But I'm just curious, in terms of the forward outlook, if you have a strong view on how value is going to accrue over time to the different pieces of the ecosystem. So you have your chip makers, you can even go back to TSMC into Nvidia, to the foundational LLMs, hyperscalers. Do you have a strong view on which pieces of the market will be strongest maybe 5 or 10 years down the line versus today, where it feels like there's a very obvious leader in Nvidia and then kind of pieces around it?
Yeah, so interesting is that none of those quant companies want to be categorized as one thing. So Nvidia doesn't want to be categorized as a chip company. So that's why they have CUDA software. They try really hard, want to build their Nvidia cloud business, DJX cloud. They try to, right now, they're building quite a bit of robotics infrastructure. So it's quite interesting to see how they want to go up on the value chain. And then the other interesting, if you look at all those traditional cloud companies, right? So we talk about Amazon, we talk about Microsoft, we talk about Google, and you look at closely into them, they're also not cloud company either, right? So a cloud is part of it, and I think Google's TPU has been performing really, really well. They haven't really pushed really hard to TPU to the market as Nvidia push GPU. But in terms of performance, TPU is amazing. So it was quite interesting is that before I say which category is going to evolve, I think everyone tried to want to be multi-category. So I think one of the trends that you're going to see some of those companies, and they want to expand above and below and then try to become a multi-category or multi-string type of companies so that they can de-risk. So that's also part of the reason all those companies, not, I mentioned Nvidia, but on the cap tables that our companies are raising, you can see that there are, there are Nvidia, there are Salesforce, there are Samsung, there are LG, there are, Amazon, there are Microsoft. They are so active. Those corporate VC firms today are so active. And part of the reason is, of course, they're looking for financial returns, but I think the most strategically, they want to build out ecosystem. So all this investment into those potentially category leaders in on the application and model side could give them more, not only just the trends and informations and understand where the market is going, but they can participate in the next category at much lower price, right? So one of the example I shared is that, people talk about OpenAI, and then they're selling off Microsoft. Microsoft is one of the largest holders of OpenAI, right? So it's kind of interesting to see people try to chase the OpenAI higher valuation. In the meantime, they sell off Microsoft because they think it's a much older company. And same thing is that Google took big hit about 2 years ago on the stock price, and then I think they're still getting hits today. But Google, I think this is 2015 or 16 that acquired 7 to 9% of the share of SpaceX. So this is also something that people don't really know about. So I think all those traditional companies, as we view it, right? So if you ask anyone, stop someone walking the street, ask them, what do you think that those companies are? They're going to say Amazon is a e-commerce company, Google is a search company, Microsoft is Office Office software, right? And then Nvidia is the chips company. It's not wrong, but it's today, none of those labels can really categorize who they are today.
Conglomerates are back in style. It's they look a little different. They're a little more properly associated with one another, with some synergies in terms of operations. But I certainly hear you. Yeah, for a while I was wondering why Nvidia's was a chip stock to me, and chips are cyclical. But I think they've diversified quite a bit already.
Yes.
As we wind down here, I did want to ask you just about the software market. If you've been a public software investor this year, it's been an absolutely horrible time.
Yeah.
And you're referencing some of the software opportunities in the private markets. I guess when you think about what AI opens up in terms of capabilities and whether that makes being a software business less defensible over time, do you have a strong view on what it means to be able to build software faster and the ability to create the infamous moat for a business?
Yeah, I mean, it's interesting. People say, well, software is going to eat the world, and now it's like, oh, well, software is is going to tank. And then SaaS versus now, like anything related to SaaS, nobody wants to invest. And I think it's a very extreme point of view, and that also create opportunities for investors who have a long-term point of view, and this is a great time to buy. And going back to why the market tanked so much, and there are different reasons, but one of the reasons is that some of the traditional SaaS companies, they were seat-based, right? So Matt, you pay $20 license, Lake pay $20, but our usage is going to be quite different. And then let's say if it's not Lake versus Matt, it's actually an agent of Lake, and then that agent can produce 100,000 more of the queries that I can do as a human. So of course, if you're selling still $20 to an agent, you're going to be bankrupt, right? Because you're way undercharged. So and that's why I think that everyone's looking back and like, okay, so let's look at the pricing strategy today. So we cannot only just doing seat per seat, but we're actually doing by usage. So I think that is going to be the type of pricing that we're going to see going forward. The second is that what traditional SaaS company are still have this. We have one product we develop for you. We customize. We charge customization for enterprise 3-tier models, and that's also going away, right? Because a lot of things today can be solved by the fast development of generative AI solutions. As some of the frontier labs are going to more and more vertical, let's say, for example, I know probably not going to name. So I would say certain frontier labs are working so hard on coding, right? So on coding and working so hard, well, that alone kills a lot of companies. Used to be like a coding services, right? That generate by human. So, and then we have them quite aggressively seeing them move towards the finance area, right? So there's a lot of fintech companies today are built on traditional SaaS model and also traditional way of building this. And now you have basically you flatten the playground, everyone's going to restart everything. So of course, there's some established older a SaaS company is going to get a hit. But also means that the flat playground is flat, everyone can start. So they're going to be a newcomers with fresh ideas and can really capture the market. And what we really like means like Sancus being spend some time on this is that, well, traditionally there are some of the industry that the deep tech technology never were able to penetrate into it. It's just because it takes so much more time to understand, so difficult to integrate, right? And then so those are heavy, older but richer industries today now really welcome this. I would say it's really easy to adopt AI at such a lower cost. So those are start booming today. And so I always kind of joke about it is that, well, think about a computer. So when my first computer, I have to assemble it physically because it's quite expensive to buy one. So I have to assemble everything. And then, of course, I have to code on the computer at the time because that was before operating system that exists. So operating system exists, Microsoft introduced, and everyone can use a laptop. But then it's really become iPad era. Then you can throw iPad to a 2-year-old, and they can be like very sophisticated users in just a week, right? So I think we're welcoming the iPad era for the enterprise now in some of the older traditional industries. I'm talking about mining. I'm talking about wholesale logistics, and some are also very highly buried by compliance requirements. And those are the areas we see a lot of new coming startups that deeply understand the industry. They are still young. They are second generation of growing up from that industry. They understand the problem really, really well. They understand what solution can solve it. They're I would say technology, but also digital AI native because they're in their 20s, right? So I think those kind of companies are doing great. And because the market sentiment is like, oh, let's not do software, and with foundation models, there's no room for AI applications. So there's consistent pricing push down the valuation of those companies. So we can still invest in those amazing companies at 5 million, 6 million, 7, 8 million, 8 million, compared to you going to AI infrastructure now is 500 million, 600 million, right? So when we invest in AI infrastructure roughly about 4 years ago, we can get pretty reasonable price because no one really understand the infra at the time. But now we still invest in infra, but we only looking at the ones that clear, very, very clear early category leader signals, and that we have extreme conviction. And then we start incubating those AI native applications, and then we enter the low valuation, and they are all built by industry experts, and they can really accelerate from the idea to revenue. So some are insane. So we just see like the company from ideation to get to revenue, it takes about 2 weeks, and they don't really need to raise. So that will change the investor landscape as well, right? Because people talk about who's going to do VC today? It's so expensive in investing in AI. Well, I'm going to ask another question is that a lot of companies today, they don't need to raise. So when you have a huge fund and you have to deploy 10 million check or 5 million check, you may not have a opportunity to enter those companies early because they only need 200K to start. And then before they can hit 5 million revenue in a few months.
Yeah.
Right. So we have companies that hit 50 million in just 4 months. So which is insane.
It's a fascinating contrast to some of those early chip startups who have continued to raise. You're seeing valuations of $2-4 billion. Moving on, and they yet to ship a chip, which is kind of interesting. Yeah. The tape outs and there's development. So the feedback loop and iteration ability within software is a completely different dynamic, and it's easy to forget why it was considered the greatest business model of all time for so long. But the market will be that way. Lake, this has been fascinating. Thank you for sharing the knowledge and particularly being so close to the ground and the actual academics on this. It's been great. I'm going to pass it over to Shannon in case there's any questions that came in from the audience.
Yeah, thank you both so much. That was such a organized conversation about such a complex and vast area. So I really appreciate that so much. Lake, I'm really looking forward to seeing you in your backyard in Menlo Park next month,
Yeah,
where we will surely dive in even deeper into this whole realm. So thank you both so much. Again, it's been great having you. I look forward to the next time.
sounds good. Do we still have time for Q&A, or I use this all the time?
We did hit time, but
Okay.
that's why I'm looking forward to the in person, because there will be no hard stop.
Yeah.
So we're gonna have plenty of time for lots of questions next month.
All right, sounds good. Well, thank you so much. And then, Matt, those are amazing questions. It's really appreciated, and I can't wait for our next conversation.
Yeah, absolutely. It was a pleasure. Thank you very much for getting into it. It was great.
Yeah, and then when we meet each other next month, the answer will be different.
Yeah, exactly.
It's a
Well,
very good
that's
point.
the thing. Yeah, this changes so quickly. So